Hi, this is Boat Anchor Audio. My name's Marty Dwyer. I have a little something here that you audiophiles may find interesting. No doubt you have some very high-end audio equipment, and more likely than not you have an audio generator to test your equipment, troubleshoot it, and repair it as necessary. Now, a lot of audio generators, they're very good for troubleshooting. Some of them, however, have a THD that's a little on the high side, a little too high to do some serious testing. Now, what I have here, and we have a diagram and more information coming up, what I have here is a very simple audio bandpass filter. It's nothing new, it's nothing unusual. Any first-year engineering student knows all about this. Very simply, it's a tunable audio bandpass filter. The gain is adjustable, the Q is adjustable. How this is used is very simple. You just connect the output of your audio generator to the input of the filter. Connect the output of the filter to the DUT, the device under test. Set your generator to what frequency you want, say 1 kC. Set the output voltage of the generator to about half a volt RMS. Now, what we do is tune the audio filter to the same frequency as the audio generator. We adjust the Q control to get it as high as possible. We do a little bit of fine tuning. Now, when you've done that, you've reduced your THD probably to a level of 0.003, 0.004. And that, I think, is a big improvement over what you would normally get out of a relatively high-end bench audio oscillator, audio generator, which is usually in the neighborhood of 0.05%, something like that. Anyway, when you get down to 0.003, 0.004, you can do some relatively high-end testing on your equipment. Okay, enough for the intro here. Let's take a look at the schematic, some pictures, and I'll show you some spectrum analyzer results we've got out of ARTA. So here we have a schematic of the filter. We'll go over this very briefly. First of all, what chip did I use? Oh, I don't want to shock anybody, but I used the old-fashioned, ever-reliable TL074. Now, why did I use a chip that came out in the late 70s? There's a couple of good reasons for it, and I'll get into it later. Anyway, let's pursue this schematic and get an idea of how this filter will work. We have TB1 on the extreme left-hand side. That, of course, is the output from your generator, your audio oscillator, which goes to the input of this filter. Continuing a little bit further, we have R1, which is a pot. That's merely a gain control. Also, we have R2. Now, that controls the Q. The Q of this is adjustable from about 5 up to about 20. Now, we don't want it too high because it may become unstable. So we have it limited to a Q of about 20. Continuing a little bit further to the right and in the center at the bottom, we have TB2. Now that's merely the 2-wire input from your power source, from your power supply. Now everybody has their own way of designing circuits that have op amps in them. Some people use a 2-wire circuit. I personally prefer a 3-wire circuit. I've had better luck with that. Anyway, we just have this rail splitter there to convert the 2-wire input that's coming from your power supply to a 3-wire, positive, negative, 0 power source. Further to the right in the lower right-hand corner there, we have a op amp that's not doing anything. Why is that there? Well, as everybody knows, the TL074 has 4 op amps on it. I'm using 3, and we have 1 left over. Now that op amp is properly terminated, so it won't oscillate, it won't take off. However, it is there. It could be used as a preamp or something like that. I suspect most people are just going to leave it alone and probably not use it. Going up to the top left-hand corner there, we have J5, J1, and J3. They are jumpers that control the range of the filter. The filter has a range of from 30 cycles to 1 kC, that's range 1. Range 2 is from 1 kC up to 20 kCs. Normally these jumpers would be replaced by a switch, but for test purposes I just put jumpers in there. You also notice R5A, R5B. That is a dual pot. That's for tuning the frequency of the filter. Going to TB3 on the right hand side, that is the output. Now you'll notice that it has 4 output terminals there on that terminal block. We have the ground, of course, but we also have a low pass, a high pass, in addition to the band pass. Now what we're interested in is the band pass. I put the low pass output and the high pass output in there. It doesn't cost anything extra. Somebody might want to use it. I doubt it very much, but if you want to use it, there it is. It's no problem. So now we get to the point of how do we use this. Well, as I mentioned previously, this is designed to reduce the total harmonic distortion that comes out of your audio generator. Even the best audio generators probably are going to have a THD of around 0.06%, something like that. Using this filter and having it adjusted correctly, we can reduce the THD down to as low as 0.003%. When you get at that level, you can do some pretty serious audio testing. Anyway, how do we use it? Well, very simply, we take the output of your audio generator, put it to the input of the filter, the input being TB1. On the output of the filter, TB3, we connect either an audio voltmeter or a scope, whatever you have handy. Next, we adjust the output of the generator to about a half a volt RMS at the frequency that you're interested in. Let's just say 1 kC. So you put your, we have your scope or your meter on the output. We have a signal going in there at about 500 millivolts, about a half a volt RMS. What we do is peak the tuning control, which is R5, for maximum output on the scope or your meter. Now, doing that initially, we keep the Q control R2 to the extreme counterclockwise position. That makes it pretty broad. We have a Q there of about 5. It makes it a lot easier to tune it. Once we have a peak, we can gradually increase the Q and maybe touch up R5, the tuning control, a little bit, until we get the R2, the Q control, to pretty much full clockwise position. At that point, you're going to have a Q of about 20. Now, we have a Q pretty high. We want to reduce as much as possible any junk, any garbage on either side of the 1 kilocycle signal that we are interested in. When you have done that, you've reduced the THD of your generator to the neighborhood of 0.003 to maybe 0.005, depending on the frequency and how well you adjusted this. This can be a little finicky, but once you get the hang of it, you can run through a bunch of frequencies with no problem. It's not that difficult to use. It just takes a little bit of practice. Okay, we went over the schematic of the filter. Here's a picture of it. I'll go through it very briefly. On the extreme left, we have a pot. That is the gain control. In the middle, there is another pot. That is the Q control. And on the far right, there is the dual pot that controls your frequencies. You'll see the input terminals for voltage, input for audio, and the 4 terminals for output, of which we're only using 2, namely the ground and the bandpass filter output. The rest of it's pretty cut and dried. As you see, the chip there is a TL074. Yeah, you might be asking why I used a chip that old. There's a couple reasons. One, the 074 has been around the track. It's been around since '78. It's very reliable. You can buy them anywhere. But there's a lot of chips out there. You can buy them dirt cheap. And they're probably dirt cheap for reasons. Maybe they're rejects. Maybe they come out of the recycle bin. Maybe they're counterfeit. For something like this, it's best to go to a name brand supply house, spend a couple pennies more, and get a reliable chip. The other reason I use something like this is it has a THD that will meet my specs. Now, I could spend a lot more money, by a high-tech chip that might have a THD of 0.0005. That's wonderful, but how do I test it? I can test down to about 0.001. That's as far as my test equipment will go. And if I can't measure any better than that, I can't test something. And if I can't test it, I can't make it. So that in a nutshell is the reason I use the TL074 chip. It meets my spec, it's easily available, it's inexpensive, it gets the job done, and that's what counts. Now what we have here are two screenshots. They were taken using the Arta Spectrum Analyzer software, and the external sound card is a Scarlett Solo 3rd generation. The first shot shows the results of the Spectrum Analyzer software before using the filter. We have a THD of 0.028%, which is pretty good. No two ways about that. The second screenshot shows what happens after we put the filter in the circuit. Again, the frequency is at 1 kilocycle. The software is set up with the same parameters, and we see that we've reduced the total harmonic distortion from 0.028% down to 0.0023%. And I think that's quite an improvement. All the more so when you consider that the cost of components, the bill of materials for this audio filter is minuscule, certainly less than $15. The only exception being the printed circuit board. If you buy 5 of them, they're going to cost a lot more per board than if you bought, say, 50. But even if you only buy 5 boards, the BOM is very, very low. Okay, we've seen what we can do with a simple, tunable audio bandpass filter, one that has adjustable gain, adjustable Q, and how it can be used to reduce the total harmonic distortion that's coming out of your audio generator and get it down to the level of about 0.003, 0.005. I might mention that how low you're going to get the THD is also a function of the THD that's coming out of your audio generator. For one, if you have an audio generator that's putting out, say, 1% THD, this filter will not get you down to 0.003 or anywhere near that. It will, however, substantially reduce the THD. If you have your standard quasi-lab quality generator that puts out a THD of, say, 0.05, this will reduce it down to about 0.003 to around 0.005, depending on the frequency and how well it is tuned. As I mentioned, it is a little, I would say, difficult to tune. It just takes about between 2 and 3 minutes of practice to become thoroughly proficient with its use. Anyway, I hope you enjoyed this little video. And in the meantime, keep the electrons flowing. We'll see you around.